Imagine standing on a world where the sky is not a canvas of blue but a shattered mirror of molten glass, refracting light in ways that defy terrestrial comprehension. This is HD 1819733b, a planet that pushes against the boundaries of our solar system's familiar order. Discovered in 2007, it orbits a star 63 light-years away, yet its existence challenges everything we thought we knew about planetary environments. HD 189733b is a hot Jupiter, a gas giant orbiting its star at a distance closer than Mercury is to our Sun. Its surface temperature soars to 1,700 degrees Fahrenheit, hot enough to melt steel. But what truly intrigues astronomers is not just its heat, but the violent beauty of its atmosphere. Silicate particles, like tiny shards of glass, are suspended in a perpetual storm, scattering blue light and giving the planet a striking azure hue. Yet this is no tranquil ocean. The winds here rage at speeds exceeding 4,500 miles per hour, faster than any storm on Earth. Imagine a hurricane that could strip the skin from your bones in an instant. This is the reality of HD 189733b's skies. The extreme conditions on this world stem from its proximity to its star, which subjects it to relentless stellar radiation, slowly eroding its atmosphere. Yet somehow it persists, a paradox of fragility and resilience. Here, the definition of planet blurs. Is it a world or a fleeting scar on the edge of a star's influence? HD 189733b forces us to confront the limits of our understanding. How do such planets form? What keeps them together when their own star seems determined to tear them apart? This is the universe's way of reminding us that diversity is not a luxury, but the rule. HD 189733b is not an outlier. It is a testament to the chaotic creativity of celestial mechanics. Every exoplanet we discover adds another thread to a tapestry far more intricate than we ever imagined. Yet, as we gaze into these alien skies, a question lingers. If nature can forge worlds where glass rains and storms scream, what else lies beyond the horizon of our knowledge? What limits, if any, does our imagination truly hold? Imagine a world where the very foundation of the planet is not stone or iron, but a crystalline lattice of carbon, diamonds, pure and unadulterated, buried deep within a molten heart. This is 55 Cancri e, a super-Earth that challenges the foundational assumptions of planetary science as we know it. Discovered in 2004, this enigmatic world orbits a star some 40 light-years away, its existence a quiet rebellion against the notion that planets must adhere to familiar rules of silicate and water. Unlike HD 189733b, a scorching furnace of a planet, 55 Cancri e presents a different kind of extreme. Its composition is fundamentally unlike anything on Earth, where carbon reigns supreme over oxygen. With surface temperatures exceeding 2,000 degrees Fahrenheit, it appears as a realm of molten rock, but beneath the surface lies something even more extraordinary. Models suggest its interior comprises a diamond-rich core, where immense pressure and heat could transform carbon into graphite, diamonds, or even crystalline silicon carbide. Picture a planet where the deepest layers are not liquid or metallic, but a network of diamonds, each one a testament to the crushing weight that forged it. This discovery dramatically alters our understanding of planetary formation. Earth, with its silicate crust and iron core, is a product of a solar system rich in oxygen and silicon. Yet 55 Cancri exists in a cosmic neighborhood where carbon may have been the predominant element. How did this planet come to be? Did its sun-like star in the constellation Cancer form it from a protoplanetary disk abundant in carbon compounds? Or did the very process of its formation favor carbon over elements considered essential for life as we know it? The implications are profound. If a planet can be constructed from diamonds and graphite, what does this say about the diverse chemistry of planetary bodies across the universe? Are there other worlds where the very core is composed of elements we have yet to fully comprehend? 55 Cancri is not merely a curiosity, it is a mirror reflecting back at us, challenging our assumptions about Earth's unique composition. We often take our planet for granted, but what if it is but one possibility among countless alternatives? Despite its peculiar nature, 55 Cancri operates under the same physical laws as Earth. Pressure and temperature shape its reality in a way that is both alien and astonishingly logical. It serves as a reminder that the universe need not be familiar to be beautiful. This mysterious world poses a challenge to our imagination, whispering across the cosmic void. If carbon can create planets, what else could the cosmos bring into existence? What boundaries, if any, does our understanding truly encompass? Imagine a world where simply existing is a slow, inevitable surrender to the gravitational pull of its star. This is WASP-12b, a planet that defies stability and embarks on a cosmic dance with its sun. Discovered in 2008 by the WASP Wide-Angle Search for Planets survey, this rogue world orbits a distant star 1,400 light-years away, yet its story is one of extremes that challenge planetary science as we know it. WASP-12b is not your typical planet. It's a shadow traveler, pulled so close to its sun that the very forces meant to keep it in orbit stretch, tear, and consume it. Its orbit, a mere 1.2 million miles from its star, sees it complete a revolution in just over 1.1 days. This proximity subjects it to extreme tidal forces, distorting its shape into an elongated football form. Envision a world where gravity is not a constant but a violent, ever-changing force, sculpting its surface and atmosphere into a grotesque, fluid work of art. What truly sets WASP-12b apart is its remarkable ability to absorb light. Unlike most planets that reflect sunlight, this world appears darker than any known object in the universe, with an albedo reflectivity as low as 0.04, absorbing 96% of the light it encounters. This makes it resemble a void in space, a shadow that seems to drink up every photon that tries to escape. Its atmosphere is likely rich in carbon-based compounds like soot or hydrocarbons, acting as a sponge to absorb light and leave no trace behind. It is a planet that does not shine, it devours light, akin to a tiny black hole, though it is nothing of the sort. The tragedy of WASP-12b lies in its inevitable fate. The same tidal forces responsible for its unique shape also contribute to its rapid mass loss. Its atmosphere is being stripped away by the star's radiation and gravitational pull, leaving it vulnerable. Models predict that WASP-12b is in its final stages, a fleeting moment in cosmic time. In just a few million years, it will be but a memory, its matter scattered across the void, its story lost to the stars. This planet serves as a stark reminder that the universe is not merely a stage for creation, but also one for destruction, where even extreme worlds are governed by entropy's inexorable laws. WASP-12b challenges our understanding of planetary survival and forces us to confront the fragility of existence in the face of stellar power. How can we define planethood when the very forces defining its orbit also hold its demise? Despite its doomed path, WASP-12b reveals a profound truth about the universe. Even amidst annihilation, beauty exists. It stands as a testament to the dynamic, ever-changing cosmos, adding a captivating chapter to the story of exoplanets. As we gaze into the stars, these questions linger. If planets can be born and consumed in the blink of a cosmic eye, what other wonders await beyond our current knowledge? What boundaries does the universe set for the imagination of those brave enough to explore? Imagine a celestial ring so vast it would make Saturn's rings seem like a single thread in an immense tapestry. This is J1407b, a planet whose ring system challenges our imagination, stretching across the cosmos like a cosmic halo spun from the dust of forgotten moons. Discovered in 2012 through the irregular dimming of its host star's light, J1407b orbits a young star 370 light-years away, its existence a testament to the grandeur of planetary architecture. J1407b's rings are not merely an echo of Saturn's splendor. They are a revelation. Estimates suggest they span 200 times the width of Saturn's rings, a staggering expanse capable of swallowing our entire solar system, To comprehend their scale, envision a ring system extending from Earth to Mars, then multiply that by a factor that makes our planetary boundaries seem insignificant. These rings consist not of ice like Saturn's, but of a swirling maelstrom of dust, rock, and debris, possibly remnants of a shattered moon caught in an eternal gravitational dance. What makes J14007b's rings even more remarkable is their complexity. Unlike Saturn's relatively uniform bands, J4007b's system presents a labyrinth of gaps, arcs, and shadowed regions, suggesting the presence of unseen moons or planets orbiting within the ring's embrace. These structures indicate a dynamic, evolving system where collisions and gravitational interactions have sculpted the rings over millennia, turning it into a celestial construction site reflecting the past and future of a planetary system. J1407b's rings, however, are not just a spectacle of size, they also challenge our understanding of planetary formation. How could such an immense ring system form? Could it be due to a moon's violent disintegration, or the influence of a nearby companion planet? The answer lies in the fundamental forces of the universe: gravity, time, and the relentless dance of matter. J1407b's rings remind us that the cosmos is not bound by our familiar expectations. It is a realm where the impossible becomes routine, and the boundaries of our imagination are as vast as the rings themselves. As we delve into this alien system, a question remains. If the universe can create rings that dwarf our entire solar system, what other forms of cosmic artistry await discovery? What limits does the universe impose on its creations, and how far can our curiosity lead us before we find answers? Imagine standing at the edge of a vast, uncharted ocean, not of water but of possibility. The worlds we've explored, from HD 189733b's molten storms to 55 Cancri E's diamond-studded depths, WASP 12b's light-swallowing void, and J1407b's majestic rings, each is a fragment of a greater truth. The universe is not a uniform structure, but a mosaic of extremes. These planets are not anomalies. They are testament to the fact that diversity is not deviating from the norm, but the very heart of existence. Consider our own solar system with its orderly orbits and life-supporting Earth. It's but a single note within a cosmic symphony of infinite variations. When we gaze upon the night sky, we see stars, yet we fail to appreciate the multitude of planetary systems hidden from view. Each world we've encountered, scorched by stellar fires, forged from carbon, consumed by tidal forces, or adorned with rings that outshine our own, challenges the notion that Earth is exceptional. Instead, it suggests our planet is but a common thread in a tapestry woven from the raw materials of the cosmos. However, this realization presents a paradox. As we uncover more about these extreme worlds, we are confronted by the fragility of our own existence. Earth, with its delicate balance of temperature, atmosphere, and liquid water, is a marvel of cosmic craftsmanship, a fleeting oasis in a universe that thrives on extremes. The very forces that shape the planets we study, gravity, radiation, entropy, are also responsible for sculpting our world, yet they serve as reminders of how precarious our survival truly is. And what of life itself? If these alien worlds can exist, could there be forms of life beyond our comprehension? The discovery of exoplanets has reignited an ancient question: are we alone in the universe, or are we merely the first to ask? The cosmos, with its boundless creativity, may harbor life not only in the shadows of distant stars, but within the fiery storms of gas giants, the crushing depths of diamond-rich worlds, or the dark voids of light-swallowing planets. As we stand on the precipice of this cosmic revelation, a profound question arises. If the universe is a canvas of extremes, what does that say about us? Are we the artists, the observers, or something beyond these roles? And if the cosmos is vast enough to contain worlds beyond our wildest dreams, what limits, if any, does it place on human imagination?